Most of us have felt it. You visit a breathtaking vista, a sunset like molten gold, or a majestic mountain range piercing the clouds. You capture the scene with your camera, eager to relive the moment, but later reviewing the photos, a wave of disappointment washes over you. The images seem flat, lifeless, failing to capture the magic you witnessed. Why does the real scene often look different from the photo? The answer lies in the extraordinary capabilities of the human eye, an organ so complex and sophisticated that even the most advanced cameras pale in comparison. The human eye is not just a window to the world, it's an intricate system that interprets and processes information in ways cameras can only dream of. Is it because the human eye has a higher resolution than the cameras we use? And is it even fair to compare the human eye to a camera in the first place? From the way our eyes perceive depth and movement to their incredible sensitivity to light and detail, we'll explore the fascinating reasons why seeing is truly believing. So next time you find yourself frustrated with a photo that doesn't do justice to the moment, remember that the human eye is a marvel of nature, capturing the world in ways a camera simply cannot. Embrace the beauty of the moment, knowing that some experiences are meant to be cherished in our memories, not just in our photos. Welcome, but before we begin, if you're new to the channel, don't forget to subscribe and turn on notifications so you never miss our latest videos. Did you know that on a dark, clear night, your eyes can detect the flicker of a candle flame from 48 kilometers away? Not only that, but every night, your eyes observe objects that are millions of light years away, such as the stars of the Milky Way galaxy. If the sky is completely clear and dark, you might even be able to see the Andromeda galaxy, the galaxy closest to our own, which is more than 2.5 million light years away. But that's not all. The human eye can do things that no camera in the world can replicate. For example, your eyes can remain fixed on a single point even when your head moves in different directions. Try focusing on a specific spot on your screen while moving your head left, right, up, or down. No matter how much your head moves, your eyes will still lock onto the same point without any issue. This is because when the brain senses head movement, the eyes rotate in the opposite direction, allowing the visual image to remain stable. This natural stabilization mechanism is unmatched by any modern camera system. Another fascinating fact is that your iris has a unique pattern, just like fingerprints. This means that every person listening to this has a distinct eye print that no one else in the world shares, not even identical twins. Your eye print is entirely unique to you. Now that we understand the incredible capabilities of the human eye, let's talk about image resolution. We often hear terms like pixel and megapixel, but what do they really mean? A pixel is a tiny unit that captures light and helps form an image. The more pixels a camera sensor has, the more light it captures and the more details it can store. Generally, an increase in pixel count results in a sharper image, though other factors, such as lighting conditions and sensor quality, also play a role. To simplify, imagine a single pixel as a tiny square. YouTube videos, for example, come in different resolutions: 360p, 480p, 720p, 1080p, and so on. A 1080p video has a resolution of 1920 pixels wide by 1080 pixels tall, meaning the total number of pixels in the image is nearly 2 million. Now, if a camera is labeled 12 megapixels, this means it can capture an image that is 4,000 pixels wide by 3,000 pixels tall, totaling 12 million pixels in one photograph. Gap 3S. So why do our photos never look as good as reality? Most of us, when we try to capture a beautiful moment or a breathtaking scene, often feel that the picture we take is never 100% satisfying. We always feel that the real view was better than the photo. The picture never seems to capture all the details, and there's always some kind of barrier between what we see in real life and what appears in the image. But why does this happen? The answer lies in the intricate connection between our eyes and our brain. When we look at a scene, our brain doesn't just passively receive information, it actively interprets and enhances the visual data. This involves a complex interplay of memory, emotions, and perception. Our brain fills in gaps, adjusts for color and brightness, and adds emotional context to what we see. This is why a sunset might look more vibrant and moving to us in person than in a photo. Moreover, the human eye has a dynamic range far superior to most cameras. While your eyes can simultaneously capture details in both the brightest and darkest parts of a scene, cameras often struggle with such contrasts. This is why photos can sometimes look washed out or lack depth. Additionally, the act of taking a photo itself can remove us from the moment. When you're focusing on framing, lighting and angles, you might miss the full experience of what is happening around you. Your brain isn't just processing visual data, but also the sounds, smells and feelings of the moment, creating a richer and more immersive experience than any photo can offer. So while cameras are incredible tools, they can't fully replicate the human experience. The next time you find yourself frustrated with a photo, remember that it's not just capturing an image, it's trying to encapsulate a moment that is multidimensional and deeply personal. Gap 3S. Now, let's dive deeper into how the human eye perceives depth and dimension. The question, what is the resolution of the human eye in megapixels, is not entirely accurate because the eye does not function like a digital camera. However, scientists and optical specialists have tried to estimate this value. When studying the retina, they found it contains two main types of light-sensitive cells: cone cells, about 6.5 million, detect colors, and rod cells, about 100 million, detect black and white vision and help with night vision. After capturing an image, the retina transmits it to the brain via the optic nerve, which acts similarly to a camera's sensor. Researchers discovered that the optic nerve has approximately 800,000 fibers, which can be roughly compared to pixels in a camera. Using this data, they estimated the effective resolution of the human eye to be around 576 megapixels, far greater than any digital camera today. Despite modern advancements in camera technology, cameras still cannot match the human eye in many aspects, such as depth perception, focus adjustment, contrast and color differentiation, and lighting adaptation. Unlike cameras, our eyes automatically adjust to different lighting conditions without needing manual settings. We don't wake up in the morning, wash our faces, and then adjust our eyes for different brightness levels. It all happens naturally. The human eye continuously records images and plays them back in a seamless, infinite video format, powered by a battery that never needs charging. And that's it for today's video. If you made it to the end, you're awesome. Don't forget to leave a like before you go, so we know how many of you finished the video. And if you have any random questions that keep you up at night, drop them in the comments. We'll answer them in future videos. See you next time. Goodbye.